It's not going to be as bad as it sounds. Let me show you first, because you know how to do regular long division. If you don't want to write this down, I'm just going to do it off to the side. You don't need to write this down if you don't want to. You can just watch and remember. If we were doing regular long division, just as a reminder, so I'm doing it off to the side here, 949 divided by 23. I would go, okay, 23 doesn't go into 9, so I'd go into 94, and it goes in 4 times. And remember, I'm just reminding you of the steps of long division, because we're going to follow these same steps. It's just going to be with polynomials instead of numbers. So then I go, okay, this goes in 4 times, so I would do 4 times 23, right? And I would subtract that, and then I'd get my remainder, and then I would bring down my next number, right? And then I would divide 23 into this, into 29. And it would go 1 time, and then I would multiply 1 times 23. And I get my remainder. We're not doing decimals, especially not with polynomials, so there's my remainder. Hopefully nobody looks confused right now. Now, let me show you how it's going to work with polynomial long division. First of all, remember, and again, you don't need to write this down yet. Let me just show you that the book is going to show the division not already in long division form. So if you don't want to write this down, you don't have to, because you won't need to write it down from the book. I'm going to rewrite it in just a second. So just take a look. This is how the book will show the problem. Here's a polynomial divided by another polynomial. So a trinomial divided by a binomial. Just as a reminder, this top one is what's being divided. It's the one that goes underneath the long division sign. So if you haven't written anything yet, this is where you need to start with our long division right here. Now, take a look at this first numerator before I write it underneath here. It is not in the correct format. I need to have my x squared first, so I'm going to reorder it, 15x squared, and it's positive. Next would be the 34 with the plain x, and that's positive. So as I reorder it under here, I keep the signs with the terms of the trinomial. So first thing is the numerator, and you can start with this step on your homework. The book will show the problem like this, kind of fraction style. Take the numerator, put it under long division. Make sure it's in the right order. And then this divided by is my divisor out here. Now, here's how we do this. We're going to start with just using 5x into 15x squared. So we just take, if this is a binomial, we only look at the first piece as we decide how many times does it go into, right? Just like I did 23 where I had to use the whole number. Here, I'm always just going to use the first term, 5x into 15x squared. Now, another way to think of this is, what would I multiply 5x by to get it to be 15x squared? Daniel Q.
3x.
Good. If I did 5x times 3x, because remember, the next step is I take this and I multiply it by 5x to subtract. So you're just imagining, what would I multiply it by? You want it to be exactly this. Now, when we do this times this, when we take our 3x times our divisor, now we multiply it times the whole thing. 3x times 5x, we already know, 15x squared. 3x times negative 2, now I use that second piece, I get negative 6x. And I'm going to subtract, just like I would in regular long division, right? So, Izzy, remember this, like I did 4 times 23, 92, and I subtracted. Is there something else, anything confusing so far? Leanna?
Can you say where you got the 2, like the 6x?
Okay, so when I multiply, let me go back here. When I did 4 times 23, I got 92, right? Here, I start with just the first piece to figure out how many times it goes into here. But when I do this step, like 4 times 23 to get 92, when I do 3x times this, I do it times the whole thing. 3x times 5x, 15x squared, and now I use that second piece, 3x times 2, 6x, and a positive times a negative makes a negative. So when we do the beginning, I just take the first piece into this. Now when I have this answer of 3x, I take this times the whole thing and write it down. Now, be careful with subtraction. Remember, subtraction is for this whole thing. It's easy to go 15x minus x squared minus 15x squared, but then I have to do minus this negative. So every time for this, I want you to add the opposite. Because this second piece is the one everybody, including myself when I do it, forget to change that one to its opposite sign. If I'm subtracting a negative, it's going to end up being a positive. So the only difference in the subtraction part is I want you, once you do it, to add the opposite so that you're flipping those signs and getting both pieces ready. Taking notes? Okay? Because I don't see a pencil in your hand and your head is down. If you don't want to be here, you can leave. Now, I subtract. Well, in this case, because I'm adding the opposite, I'm now going to do that. So, I've added the opposite, so it's now addition. 34x plus 6x. Notice, guys, the like terms are lined up. So I can add these. I get plus 40x. 15x squared minus 15x squared, gone. Every time this first one will drop out because we have matched it. Next step in long division, what do? I bring down the next piece. In my plain long division here, I brought down the 9. Here I just bring down the next term. Now, just like over here in regular division where I did 23 and now I went into 29, now I'm going to do the same thing. But again, when I go into, my grandpa used to call these the goes intas. This goes into this. How many times does it goes into? 5x goes into 40x. Think about, again, what would we multiply 5x by to get it to be exactly 40x, Carissa? 8. Right, so again, that goes into 5x goes into 40x. The other way to think about it is I'm going to multiply this. 8 times 5x makes 40x. You always want it to match exactly. Now when I multiply the 8, I multiply it by the whole thing. 8 times 5x, I already know, 40x. That's why I picked 8. Why Carissa picked 8. 8 times negative 2, negative 16. I subtract the whole thing, which means I'm going to add the opposite. So I just flipped all the signs. In this example, no remainder. Negative 16 plus 16, 0. Negative plus 40x minus 40x, gone. What's my answer? Here it is. Think about how you could check your work. The opposite of division is multiplication. If I take my answer times my divisor and FOIL them, I'll get this. We're going to do another one. Anybody having fun yet? Oh, some of them are. I know it's better than the fractions, right? Okay. All right, another one. I'm going to try to just do one more. Now again, you don't need to write this down, but I want to show you how it's going to be shown in the book. So if you don't want to write this down, that's fine. 2a cubed plus 5 over a minus 3. Now this one I'm showing you also because it has one more thing I need to show you in it. As I put this numerator underneath, notice what I've got. I've got an a cubed, but nothing else in terms of variables. Think about how things would normally go. A cubed, if we had it in order, a cubed, then a squared, then plain a, and then finally my plain number. If we are missing, right, so again, you don't need to write this down, right? If it was x cubed, x squared, if we were going in order, then x, then the number, right? That we start with the biggest exponent when we put these in order and we work our way down until we get to the plain number at the end with no variable, right? So that's kind of the standard order for this. This is missing the squareds and the plain x, or in this case a. We need to hold a space for those. And as we start to do the long division, you'll see why. So just trust me. Let me say, if there's any exponents that are missing, You need to put them in. How many a squareds do I have? None. But I need to hold that place. How many plain a's do I have? None. But I need to hold that place. And again, you'll see why as we start to do the long division. Hold on just a second. Let me just show you, then I'll take your question, Izzy. On this one, let me just show you guys. I'll put it back up in a second. Notice when I did my multiplication, I said this, that the like terms line up. If we were missing these, missing exponent variables, things wouldn't line up and we wouldn't be able to subtract. Izzy, question?
Are those zeros?
Those are zeros. Those are zeros. Because here's what I said, Izzy. I said, how many, wait, there's no a squareds and there's no a's. How many a squareds do I have? 0. How many a's do I have? 0. Okay? Now, I'll show you why we have to do that. We put our a minus 3 out front. Remember that to start, we just do our goes intas. A goes into 2a cubed. How many times does it go into? Or, again, the easier way to think about it, I think, is what would I multiply a by to get it to look like this? Daniel?
2a
squared. 2, to get the 2a squared times the one that was already there gives me a cubed. Okay, now I take that 2a squared and I multiply it times the whole thing. 2a squared times a, 2a cubed. You always want that first one to be exactly the same, because then when we subtract it, it cancels out. Now I have to do it times the negative 3. 2a squared times negative 3, negative 6a squared. Look at how this lined up right here. If I had a 5, if I didn't hold these places and a 5 was here, I'd have 5 minus 6a squared. Well, I can't subtract that. They're not like terms. Again, if we didn't hold that spot, the 5 would be right here, and I can't subtract 6a squared from 5. So whatever missing exponents are in there, you fill it in with a 0. Subtract the whole thing means I'm going to add the opposite. It ends up being negative 2a cubed plus 6a squared. Now I combine the rows. 0 plus 6, 6a squared. Again, my 2a cubes cancel out, and that should always happen with that first term. Now I'm going to bring down my next term, my 0a. Again, my goes intos. A only goes into 6a squared. Right? We just use the first ones when we're doing how much it goes into. Or, if you prefer to think about it, a times what will make 6a squared? Jaden?
6a.
Okay, good. Now, let me just point out that sometimes if this were a negative here, what if this was negative 6a squared? Well, this would become a minus up here, right? We'd have to go positive times a negative to get a negative. So just be careful, there might not be too many of those, but it could exist. Okay, I take my 6a and I multiply it times the whole thing. 6a times a, bless you, 6a squared. 6a times negative 3, negative 18a, and it's lined up here with my 0a. My like terms are lined up. Again, if I didn't have that spot, I can't do anything with 5 minus 18a. Wouldn't work. Because I'm subtracting this, I'm going to subtract the whole thing. Now you don't have to do the parentheses, but I show those to show we're subtracting the entire thing, and we need to add the opposite of all the pieces to make sure we get it correct. So I'm going to change it to addition, and I'm going to go inside and flip my signs. It ends up being negative 6a squared and positive 18a. Again, just like always, the 6a squareds cancel out. 0 plus 18a. 18a, and I bring down my 5, and we're almost done. Again, going back to just our a, goes into 18a, how many times? Or what would I multiply a by to get it to match? Carissa? Times 18, 18 times a, 18a. 18 times negative 3, I feel like doing mental math, I'm going to cheat and look at my book, negative 54. You can use your calculator for that part, of course. I'm gonna subtract that whole piece. Now in this case, I am gonna have a remainder. That's gonna happen sometimes, and that's okay. I add the opposite. So 18a becomes negative, 54 becomes positive. The 18a's cancel out. 5 plus 54, 59. Now I'm just gonna show you one other way you could have your answer looking. I just put remainder 59. You can just do that, that's fine by me. I'm gonna show you the way the answers look in the book so that when I show it to you Monday, it hopefully won't freak you out thinking you have the wrong answer. Here's how the answers would be shown in the book. 2a squared plus 6a plus 18. Now, the way the book is gonna show this is technically this remainder is how much is left out of my divisor. So the book shows it like this. 59 left over out of what I divided. You can write it that way if you want. But you can also, as far as I'm concerned, just put remainder 59. If you can get the right answer and you want to show it R59, that's fine by me. That is what it is, it's the remainder. But just so you know, the book will show it when I show it. This last piece with the fraction, that's the remainder. And it's just saying it's this much left out of what I was dividing. But this is fine right here. Any questions on the steps I did here? Does this explain better why we had to hold the places? You see that? Okay. That's all I'm going to show you. That's all you need to know.